Is this working? Let's check. Oh, fuck off. Is this working? Yes, it looks like this is working. Right, good. It's working. Right, it's showtime, folks. Okay. So yesterday night I was playing around with the FEA of this front wheel upright. Now, for those of you who don't know, FEA stands for finite element analysis. So what does this mean? It means it's very complicated to study the forces that are being applied on such a complicated looking geometry. Therefore, what we do is we decompose it into much simpler parts, analyzable parts. I don't know if that's a word, I just invented a word. Anyway, what that means is it allows us to see the reaction of the part to different forces. So first of all, we are going to do the FEA of the load under turning, heavy turning. I did try and do it yesterday. However, I thought I was way too close to the limit, so I made the part stronger. But in the end, I was actually 10 times lower to the limit. So I want to be 2 times lower as a target. The limit is what we call the elastic limit. So if you take any material, we'll have an elastic limit. So you can, I don't know, this camera mount, for instance, you see I can bend it a bit and it goes back to its original shape. But if I bend it a bit more, it will be permanently deformed. That's the elastic limit. And ideally, we'd like to be at a value that's half of the force needed for that. So, without further ado, we're going to launch our simulation. So, new simulation, I'm going to call it Heavy Braking 3, right? Static, bloody hell. Heavy braking 3. Sorry for. There we go. Alrighty. So first of all, what you have to do in these cases is, is say where it's gonna be fixed. So, well, the places that it's going to be fixed. Hang on, what am I doing? Why? Wait. Sorry, I got lost. Yeah, it's because I asked for help. I didn't need help. I know what I'm doing. That's a lie. I spent the evening yesterday trying to do it. So, it's working right now. I launched the stream too early. I just got the Instagram notification. So what I'm doing right now is basically saying where I'm sticking. Well, this is not supposed to move. So it's not either supposed to move here and here, which are that's where it's not going to be moving because that's where my bearings are. So all these highlighted blue parts are like fixed. They're anchors. Right. So all of this doesn't move. Neither does that, because that's where my part is being held on. I forgot to do a chamfer in here. Doesn't really matter. It will be just fine. So next, yeah, that's what I did. Because I was on the wrong thing. Okay. Right, that's done. Who's texting me? Myself. Wonderful. Wait, I need to share the thing on Instagram. Just a second. Just taking a little picture. And let's take the link. Link. Where is it? Where is the link? I'm an idiot. There it is. Hang on. Gotta find it. I always lose like so much time doing this. I need someone to do it for me. There we go. Story done. Keeps turning off. It is truly a mystery. So, beefy, get rid of. Yes. Yeah. New video. Source. Yes, that's me. Hello. How are you? Okay, we are so back. So now that we've put our anchor points, what we need is to put a constraint point. So we go back into simulations. This one. So selection. Well, I messed up. This one. Modify it. This isn't fixed. And you know what? I'll just delete all the selections and do it again. There we go. There we go. This is fixed. This is fixed. There we go. And the last one. There we go. Okay. That's good. Now, as we said, simulation. This one. Distance mass. So, let's say it's pushing one way, so it's been applied here and in the same direction for this one, because the force is pushing into one side of the upright, so it's only being applied on the face of the upright, of course, because it's going to be up and down. So the face of that cylinder and the flat part on which the bearings will be pushing. So okay, we are Gucci. Yeah, that was horrible thing to say. Right, and I need this to be at the distance at which the wheel center is going to be, because that's where it's being applied. So it's 45 of distance plus, sorry, 47 if I remember correctly. 47 plus, well, my upright total, that's from the center, right? So my upright total is 100, so it's 50 plus 50. Alrighty, and that's that. Yeah. Okay. So that was, when I looked on the internet, it was 2500, right? 0 on it Y and 4500, right? Am I going the right way for Z? No. Yeah, that's... So at this point of application, the wheel is pushing into, at this point, right? So you see, I've got the reaction going up, going opposite gravity, and I've got a wheel turning, pushing into that. That's basically the forces that are acting on my wheel upright when I'm doing a heavy turn. So now that this has been done, next step is to do this. You just do this. Yeah. Wait. I think I messed up. That wasn't what I want to do. Yeah, that's what I need to do. So that's the meshing. So that's I'm subdividing the entire. Wait, hang on. Are you guys seeing? Ah, yeah, that's supposed to be the chat. It's not working. So I guess hang on, we'll just destroy that. Yeah. Okay. So I went to the chat. So, like I said, when I explained what FEA was, you see it's being subdivided into a million of little parts that are more easily to define. Now, I'm just gonna apply a little control. So I'm gonna choose a few parts in which I want a bit more definition. So these would be these parts, right? It's making the computer lag. It really doesn't like that. Wait, hold on. I'm basically just asking to give a little bit more definition on the calculations, a bit more precision on these bottom cycling, which are the parts that I've either anchored or defined as receiving force. That way I can see that should be the place where I should get the most significant force. So that's that. So here I just define the density just a bit more, yeah. Wonderful. Allow, right, and now that this is done, what I have to do is simulation, execute the study, right, and now it's showtime, folks. Right, let me see this. So here we see that the max constraint is 4.3 plus 70, and here our elastic limit is 5.05 plus 80. So that's we're very far from the max constraint, and it's here. So that means we can make it lighter. So first of all, what I'm seeing is again really no constraint here, like 0. So what I'm thinking is making some lightning pockets around here, and I can also make these slightly thinner, because I mean these are the places where I'm getting the biggest deformation. Let me just let me see halfway what we get in. It's not letting me see the inside. So, okay, we're just gonna hide this. Go like so. Otherwise, I can't see. Right. Bugger off. Can you? I don't want to see you. I don't want to see you. And I don't want to see you. Okay, wonderful. Right, we're gonna go on the exactly this one. Perfect. Okay, sketch. Convert. You fuck. Sorry. I have to mind my language when I'm on the internet. Actually, just in general. There we go. Sketch. what I want is this to be parallel. Ah, I'm just going to do a tangent that way. Okay, now this one. How's it parallel this one? Okay. Okay. Now, this just do. That's too big. Yeah, that's good. Okay. Right. Right. Wonderful. And now we do symmetry. Sketch symmetry. All these guys. With this. And now, okay. And now we destroy this extruded matter. Wait. Hey. I forgot. What is happening with my SolidWorks? Why is I don't care that updates are available. Don't ask again. Ah, no, stop logging me in. What? Thank you. No, I just want to. Now you're seeing all my stuff. My data is going to be leaked. This is so annoying. I have no idea what this is. I mean, it's 3-year experience, so I just can't get rid of it. Symmetry. So which one is it? Is this one? I'm trying to get rid of this one. Like, does anyone know how I can get rid of this? But there's no one watching, so of course nobody is going to know. I have no idea how this works. No, I'm fucked. There has to be a way. I'm just gonna do this extrusion, and then I'm just gonna quit. Right, all my stuff is gonna be on the internet and it's gonna be stolen. This is taking a long time. I'm sorry about that, folks. Doesn't matter, nobody's watching. the surface. Oh, are you kidding me? Yeah, of course. So, I'm just going to do like so. So 10 isn't enough. Let's say 30. Yeah, 30 is good. All right. Okay. We're Gucci. It's a horrible expression. However, it seems that I've destroyed. I don't see my what's it called? Study again. I'll just edit that a bit to make it a bit thinner because that's way too thick. That's not what I want to do. I don't want to do a sketch. Here we go. 2.5. There we go. Okay. How does that look? Right. So we're going to do the study again. Now it should go a bit faster. New study. 4. Okay. Yeah, but where is it? Where is it? Again. So if it already exists, it must be somewhere. What's this? No. Okay, property manager, configuration, and it's not here, is it? Equations. No, it's not here. Okay, fine. Okay, breaking 5 then. Okay, let's try that again. Fixed geometry. Okay, here we go. Let's try and do this quick. This one. This is fixed. 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 All right. What else is fixed? Okay. That's good. All right. Now, loads. This one. So the load is being applied on the cylinder and on one side. Okay. It's being applied at 0, 0. 50 plus 45, that's 95. Sorry, 47, 97. Right. Newton in X, we said 2,500 because X is up and down, yeah. And here we said 4,500, 4,500. All right. Now, meshing. Create a mesh. Yes. Okay, it's working now. We're gonna do just a little definition, control. Here we go. This bad boy, this bad boy, this bad boy. Right, wonderful. This bad boy here. Hey. Hey. I love how when I get angry, I just sound like an Italian. Like, hey, what are you doing? Yeah. There we go. Okay. Okay, that's my mesh right here. And now execute. Showtime. Oh, it takes a while. Yeah, we still got so much margin. I mean, it's so Gucci. Like here, there's no problem whatsoever. And how much does this weigh? I mean, should I make it lighter? I mean, that clearly means I can make it lighter. Wait, hang on. You know what? I'm gonna save. Oh, I've just found all the studies. They were all here. Is there any way I can delete the study? Ah, okay. So I'm stupid. It doesn't matter. I'm just gonna ask for a report. Okay. Yeah, I can't believe I've just found them. So what it does there is, well, this first of all, and then it generates me on Word a full report of the study. And the next study that we're going to be doing is the braking, I think. Hang on, let me get my notes. Yeah, I'm, as always, very, very well prepared. Okay, heavy turn. Okay, yeah, it is heavy braking. And look what it does. It does all this. It's pretty long. But you know, because I'm lazy, I'll just, like, I'll keep that off. Bloody hell. Yeah, don't do that with your mouth. I'll just, I'll read it if I need it. Like, I'll put it in Claude and ask him what does he think about it. No, okay. I'll do maybe a bit more than that. I called it Hey Bay Braking. Hey Bay. What is even that? Okay. Hang on. Yeah, I found it. If I see. Yeah. My brother's sending me things. I don't know what he wants. What is this? I have so much junk. Right. I'm just gonna rename that bad boy. Rename heavy braking. There you go. Okay. Good. Now, new study. Oh, did I say heavy braking? It's not heavy braking. That's heavy cornering. Okay, now I have to redo a report. It doesn't matter. Lots of waiting today on this live stream. But anyway, there's nobody watching, so. Right. Here we go. Now we can do our new study, which we will call heavy braking. Braking, right. So now let's think about it. So in heavy braking, well, it's always going to be the same places that are fixed, right? We agree on that. So this is fixed, right? These are the fixed places. So let's see. This, so I know which, more or less, which forces I'm going for. There is a force that's going to be in the same place, of course. We've got a vertical force towards the top. No, towards the bottom, because of course my car brakes towards the front, pushes down. So we've got a vertical force down, which is of 2,500 newtons. So that's that. And I've got, wait, hang on, that's, yeah, no, sorry, it's the opposite. Because my car is going down, the force should go up, because it's the reaction force, right? So force going up in vertical, and the car is going to be pushing this way. So the force is going to go that way. So that's the front, there's the back. So up, back. But also I want to add a force going down here on this place, because the wheel, so the wheel goes like this, turning that way. So if I brake it, this is going to want to go with the wheel. So I'm going to have to brake that. Okay, let's go. So first of all, we're going to do this. So selection, always this. This is 97. Right, and what did we say? We said in X, it should be going up. Going up. And we said to, let's say 3,000 for both. That way it was sure. There we go. That way. And what did we say? We said reaction going back, correct? Because the car is going to push it, it's going to be pushed forwards, and when you brake, it's pushing it back. So yeah, so pushing it back, that would also be 3,000. All right, so that's that. And I want to add a force here. Yeah. Hang on. I don't like that. Centrifugal, distributed mass, pressure. No, it's not pressure, it's a force. It's in Newton. Force. And it pushes this way. Let's say 3,000. All right. Let's do our mesh. It always takes so long. Any viewers? Of course not. Right. Let's define a meshing control. Okay. Here. I forget. I forget everything. Let's add this a bit more detailed, yeah. Give it a bit more detail here. And yeah, just here. All right, just a bit more. And now we can execute order 66, can't we? Ouch. Okay. So something happened. So of course the main points are being constrained is here, because I'm putting a lot of force. I'm showing my screen to you for no fucking reason. Putting the force here and here. So what's being deformed? Can you go away? Thank you. Well, what's being stressed is that part here. So nothing new, nothing surprising here. I'm so quite happy with all this, very happy with this, and very happy with this, because I mean, we are still so far, we're so good. I mean, we're not that good, but I mean, look, we had 2.48, so almost 2.5. That's exactly what I want in terms of I want it to be half. So this is the max. 2.48, and this is our limit, and I want my max to be the half of my limit, so spot on. So that's very nice, very nice. Right, so that's for heavy braking. I want to check what happens when we have a heavy vertical hit, like we hit like a I don't know, a curb or something. So same thing, we're going to around 3,400. Let's say 4,000 newtons. That way it's a really like evil sausage curb. Right, so new study. Wait, I need to rename it. Vertical shock. I wrote it like meme, in the meme way. It's funny. Yeah, nobody's laughing. I know. No, I don't need your help. Bugger off. Right, so let's get cracking. Fix as usual. I know I maybe could have duplicated the last one we did, but yeah, can't be bothered. Right, so this is getting fixed. Now I'm realizing I'm literally giving a class in FEA. Actually, I discovered FEA on SolidWorks yesterday. Like, I usually always just made my model and put them on Patran. And honestly, I like it on SolidWorks. It is pretty neat, I got to say. Anyhow. Loads. Ah, yes, it's still displaced, right? Because the load is happening at the wheel. So, load. Is this one? So as per here, we have 97. Okay. And our vertical is X, all right? So let's say 4K. And 0 on everything else. Alrighty. That's good. Oh, so yeah, of course, we'll select an entity. Well, it would only be on this, right? Because we're only looking at vertical. There's no lateral or anything, so these have no impact whatsoever. Right, I'm tired of seeing these lines. I'm tired. It's a big word, but it's a strong word, but it is really annoying. Right, let's create our mesh. Here we go. What does this idiot want? It's funny how nobody texts me, and then as soon as I'm streaming, people start texting me. Okay. Random selfie. Right. I want more detail, my friend. Here we go. I always, some would say I'm stupid. I can't even articulate my words properly. Like, I had a really nice man do me a recommendation letter, and he said I was articulate. I can't even express myself properly for like 5 seconds. But that was very nice of him. I mean, also it's, being on stream is actually really difficult to do, like streaming and to do real stuff, like especially on the simulator or on this, because you have to actually think about what you're doing. It's not like being on Minecraft or on open front. Like if you want an open front, like if you want an open front live stream, that'll be funny. What did I do? I think I messed up. What are those? Okay. I think we can execute order 66. I'm a bit lost here. Sorry. Brain goes places. Ooh. Wait. That's what I want. If one misses, the rest is just... So once again, we are really good. I mean, it doesn't look like this because it's obviously... Okay, maybe I didn't mention it, but like this deformation is like multiplied by like 20,000. I'm exaggerating, but maybe it's not 20,000, but like it's heavily... it's very heavily modified. So hang on, if I just go back into the von Mises constraint, here I mean, look at that. We're so far. Like we're 10 times smaller. Yeah, we're good. We're like really good, man. Okay. However, in heavy braking, we weren't that good, so obviously I'm not gonna touch it too much. I'm happy with the weight. So honestly, I think we're done for that part. I think we're done. And it's only been an hour. All right, let's do a little report. I love that too. It's like, I don't know, I just love it. And once that report is done, we're going to go back on the I just want to design a like easy brake caliper quickly. So I'm just going to save that and get out of this. And I want to do a new part. However, I did forget. I forgot which one we took, so we just have to go back. Like I noted it down, but I can't remember where. Okay, brake kits, advanced manual search. This is like the 100th time we've been on this. Okay, so front kit. Axle loft, rotor diameter was a 1020. It's loading. Can't remember exactly the shape. Hang on. Where's the edge? I mean, how cool would it have been to have like these huge 6-piston ones? But like honestly, it was a bit of a kill. I mean, look at this. It looks so cool. Why is there so many? Hang on. It's not listening to me, right? Because I said 1020. Still loading. There it is. So Dyna Pro single left front midget. It was one of these two. I think it was the same. It's crazy because this looks like the same caliper, but it's just like a different rotor. It's like double the size. It's like more than double the price, like 3 times the price. Okay, hang on. Let me check this bad boy right here. So I'm just gonna put this here. Okay. So hang on, first I need to convert inches to real units. So 10, come on, 10.20. That's 259.8. Wonderful. Okay. 259.08. There we go. Okay. Wheel racing. Radio got disconnected. Hello. Oh, you're live. Yeah, it's here. Okay. So that's that. Next. How thick is, how big are they? 388 for inside diameter. Oh, sorry, 0.0516. 0.516, that's 13.164, and there are 3 of them. Now there are 2 of them. Okay. So that's 13.1064. Right, and now repetition. It's this guy right here. And I want 3 of them. Wonderful. Okay. Alright, and this one doesn't exist, right? Okay. Far side inside diameter 388. 3.88. 98.552. 98.552. All right, and I don't know how it looks to you guys, but if I take this, and it looks like these openings here have more or less the same diameter as this. Um, Hang on. Okay, definitely are. God damn it. God damn it. Oh, are you? Why is? Yeah, sometimes things just go wrong when my brain doesn't work. That's what happens when you have a monkey brain, as I do. Alright. Bloody hell. I've lost it again. No, that's not the one.